Hey everybody, hope you're having a nice day. This video is going to show you some basic usage of Tethys, which is a Python package for downscaling water demand data. Well, what does that mean? Well, GCAM is modeling water demand, among other things, at the region scale with 5-year time steps because it's representing these long-term global multi-sector dynamics. But you might want, finer scale water demand data if you're doing an analysis of scarcity, or if you're trying to couple GCAM with a hydrology model that's operating at finer scales. So what Tethys lets you do is generate high resolution water demand data that's consistent with coarser scale dynamics. A little background on how it does that, at least for the spatial downscaling, is that for each sector, Tethys uses a spatial proxy. So what that means is assuming that the distribution of water demands for the sector follows the distribution of some other variable. For example, for using population as a proxy for municipal water demands within a region, then a grid cell containing 1% of the region's population is going to be assigned 1% of the region's water demand. Anyway, the conceptual background is laid out in detail here, as well on the documentation, as well as the details of the configuration file and using Tethys. We've got a getting started guide that'll let you get started. But if you just want to have somebody talk you through things and show you some basic functionality, then that's this video. So anyway, as a prerequisite, you're going to need Python version 3.9 or later installed. As well as Java on your path if you're querying a GCAM output database. Once you've got that taken care of, you can install from the GitHub page using pip with this command here. After that, you can import Tethys and then download the example data with this command, tethys.getExampleData. That'll download to the default location. It'll take a little while, so you might want to pause the video, get that going. Anyway, I'm going to show you some basic usage here. So once everything's together, we've got the example data downloaded to this default directory. We're gonna specify our configuration file is this config example.yaml, and then we're just going to run it. Pretty quick because we're using a pretty simple config file that I'll show you later. But first, we're going to generate a little map from it just to see what it looks like. So yeah, we've got municipal water demands for 2010 downscaled. Anyway, we'll take a look at the config file real quick, so you can see how that works. So we specified years 2010 at 1/8 degree resolution, and water demand is withdrawals rather than consumption. You can have the outputs into a netcdf file, but I've just kept them in memory for this video. Our input data is coming from a CSV, but you can have it come direct from a GCAM database as well. But what it looks like is this region, sector, year, value data table. We specify the proxy files here. So in our data population folder, we have ssp2 2010.tif, and we declare the variables present here are population, and that it's for years 2010. And then we define the downscaling rules. So we say municipal is proportional to population. And lastly, this map files lets us specify the maps containing where these GCAM regions are on the grid cells. So if we wanted to make a simple change, let's operate at 1/2 degree resolution and rerun everything and see how that works. It goes fast because it's lower resolution, I should say. And you can see the outputs there. Another basic change we can do is we can add another year. So this folder also has a 2020 population file, and we can add that here and ask to run year 2020 as well, because that's in the example data. We'll save that, run the demo again, and we'll plot the 2020 outputs. Another change, so this is we can do convenient for 2 files, but if we want to add more, we actually have a convenient way of doing that since these are systematically named. So we can replace that year with just this year in brackets here, and then add turn this year into a list, so 2010, 2020, 2030, and get rid of this extra one, and this lets us write sort of in a condensed form. And this is helpful if we have a whole lot of years. We can also linearly interpolate to get these intermediate years, since GCIMS is a five-year time step, and this proxy data is at 10-year time steps. And we can just go ahead and save that and run again and plot the 2025 outputs. And boom, so it's super fast to make these kind of changes. The user guide shows you some more of the example files. We can define more complex rules. For example, GCAM has a sheep goat category that's sheep and goat, and there's a proxy files that are sheep and goat, and so we can specify that we should add those to make this kind of hybrid proxy by specifying something like this for the sheep goat sector. So there's a whole lot of flexibility here. And yeah, check out the user guide for more. You're always welcome to start a discussion on GitHub. Anyway, have a nice day. Thanks.